Good morning, ladies and gentlemen. Today we're going to continue our romp through transformations by beginning to tackle reflections. Reflections are the second transformation we've been tackling so far. We've done translations. That's when we take a shape and we slide it somewhere else on the graph. Reflections are when we're going to take this shape and we're going to flip it onto the other side of a line, usually one of the axes. It could be a different kind of line, but usually it's just one of the axes. So let's do that. In this video specifically, we're going to try and flip it over the x-axis and see if we can come up with a little mathematical rule. That way we can reflect things without using a graph. Just save some time in the future. So let's dive in. Reflecting the shape A 9,8, B 8,3, C 3,3 over the x-axis is a very simple feat. Just a little bit of terminology before we jump in. You may hear me call it the x-axis. You may also hear me call it the line of reflection. They are synonymous for one another in this example. The line of reflection simply means the line in which I am flipping my shape over. This could be the y-axis, in which case my line of reflection would be the y-axis. But for this example, my LOR, my line of reflection, is the x-axis. So you may hear me say that a little bit. I just want you to be prepared. I'm talking about the x-axis and vice versa. Okay, reflecting a shape. It's actually a very simple procedure. To reflect a shape, we're going to reflect each point. Just like translating, we translate each point. To reflect each point simply means to place that point the same distance away from the line of reflection, from the x-axis, just on the other side. So for example, we've got B right here. B is 8,3. I want to move it on the other side of this x-axis, but I want it to be the same distance away. So B right now is 1, 2, 3 away. B prime is also going to be 1, 2, 3 away. And then I just place my point, B prime. There you go. That's simple. Just move it on the same distance, just on the other side of the axis, or the other side of the LOR, the line of reflection. Let's label this point. This is 8, 3, 8, negative 3. In fact, I'm going to label them down here, actually. 8, negative 3. Just keep track of them over here so that we can make that rule later. All right, let's do C to C prime. C is 1, 2, 3 away from the x-axis. So I'm going to count 1, 2, 3 away once again. There's my C prime. That is 3, negative 3. So 3, negative 3. Awesome. And now A prime. A prime is, well, A is 1, 2, 3, 4, 5, 6, 7, 8 away from the x-axis. So I'm going to take A prime and make it 1, 2, 3, 4, 5, 6, 7, 8 away from the x-axis again. A prime, and that is 9, negative 8. Boom. 9, negative 8. And once I connect my dots, you're going to see I'm going to have a reflected shape. A shape that is not only just on the other side of the axis, but is also completely flipped, a mirror image of the other one. And you know how, if you're feeling saucy, I like to shade in my shapes, my transform shapes. I think it makes it look a little nicer. But yeah, look, it is not only just moved, it's been flipped. Perfect. And it's that easy. You just count the distance away. But let's say I didn't have a graph. Is there a way, just like in translations, is there a way to reflect a shape without a graph? Absolutely. And in fact, I want to see if you can come up with the rule here. I just want you to notice that A and A prime use the same numbers, but there is a key difference between them. Can you spot that key difference? Pause the video and come back to me when you've spotted that difference, or come back to me when you've given up. All right, I'm just going to label this reflect across x-axis. And this is going to be our rule for reflecting across the x-axis. Every point starts with x, y. And if we look here, we have the same number for x, the exact same number. 9 became 9. 8 actually stayed 8. 3 stayed 3. So my x value did not change at all. So I'm just going to write x again. We didn't change the x value. And we didn't really change the y's numerical value. It's still 8, it's still 3, it's still 3. But we did change its sign, and that is the rule right there. When I'm reflecting across the x-axis, a really easy way to do that is just to take the points and flip the sign of the y-axis, of the y points, the y values. So 9, 8 became 9, negative 8. 8, 3 became 8, negative 3. 3, 3 became 3, negative 3. And let's say I had a point D, and let's make that point, 4, comma, negative 2. If I were to reflect it across the x-axis using this rule, D prime would be 4, keep the x the same, and just flip the sign of the y. Negative 2 becomes positive 2. That's how easy it is to reflect a point across the x-axis. We have made the rule for this, so I'm going to write it up here. Once again, we keep the x the same, but we flip the sign of the y value. And that's the rule. In the next video, we're going to do the same thing, but try and find the rule for the y-axis. I'll see you there.